right, you guys, we're looking at 3, 4. What we're trying to talk about today are inverse functions. You're like, wait. And this is good because this is talked about in AP Calc as well. You guys, in order to write inverse notation, here's how we do it. We say f to the negative 1. It's got a little negative 1 superscript. Let me change my f a little bit. F to the negative 1. And we'd say that of x. If we write it like that, that just means the inverse of x. Denotes the inverse of f of x. Okay. So the inverse, just so you know, may not necessarily be a function. Okay, the graph of a function or a relation and its inverse, you blank the x and the y. Yes, you sure do, Mr. Sean. You switch the x and the y. Boop. Okay. If you flipped the x and the y, does anyone remember what line we're reflecting them over?
The y. X. Y is equal to x.
The y equals x. So close, Sean. The y equals the x. And what does that look like? I'll show you in just a second. Awesome. You guys, this function, we know what this is going to look like. My parent function's absolute value of x. What's that going to do? Plus 3. Negative 1/2. Wider. Very good. Okay. Let's go do it. Let's go graph it. Let's go up 3. We're going to go down. And my slope is now going to be 1/2, right? So I'm going to go down 1/2. Could you list me some points from this? Give me some points. What's that point? Oh, tutu. I love that point because I was a ballet. I love ballet. Tutus, you get it? Okay, what's this point? 0, 3. 2, 2. Oh, wait, look at how I'm writing this. What a goober. 0, 3. 2, 2. What else? Negative 2, 2. Negative 4, 1. And 4, 1. You guys, Mr. Sean Livingston Sanders said, okay, well, the inverse, you just switch the x and the y. You just switch them. Mateo, what would you say the inverse will have of a point? If this one had 0, 3, what's this guy going to have? 3, 0. He mumbles. What about this one? What will 2, 2 turn into? 2, 2. What about negative 2, 2? 2, negative 2. Negative 4, 1. 1, negative 4. 4, 1. 1, 4. So you guys, let's go plot these points. Let's go see what they look like. I'm going to go put them in blue. I should have matched the colors, but I didn't. 3, 0. 2, 2. 2, negative 2. 1, negative 4. And 1, positive 4. Boom. Here's its inverse. So, does this look like my blue and my black graphs were reflected over the line y equals x? Yeah, that's what an inverse always does. Kind of looks like a spider. Would you say this inverse function, maybe we label it. You guys, let's go do this. Let's say this one is the inverse and this one is my function. This is my function. Blue is my inverse. You guys, is the inverse a function? By raising your hand. Is the inverse, Ben?
No.
He says no. Ben, how did you know? Exactly. Because it passes or fails the vertical line test. Beautiful. Fails the vertical line test. He said, when I draw this red line, I hit that graph twice. Therefore, it's definitely not a function. Agreed. So now I said, hey, go find the inverse of this function. Then graph both the original and the inverse. Whoa. You guys, to find the inverse every time, we always start by, I think Mateo might have said it, you switch the x and the y every time. So you guys, let's go flip our x and the y. Do you agree f of x is really just fancy for y? So we're going to flip it. What am I going to put here? This was a y. Let's flip it, though. I need to change y and x. I need to change them. What's this going to turn into? Yeah. So we got x equals y plus 3 squared minus 5. You guys, in order to find the inverse, first you flip the x and the y, then we go solve for y. We got this. What would you do to solve for y? Add 5. Then what do we do? Getting y by itself, I heard it. Square root. Yep, very good. X plus 5. And just so you know, you guys, what's the square? Actually, I'll come back to it. Final thing to get y by itself. Subtract 3. Are you cool with saying root x plus 5 out of the root is a minus 3? Let's go to our original. What's my parent function of this guy? Which way are we taking my x squared? Left 3, down 5. Can we do that? Let's go left 3, down 5. Here's my new vertex of my original. Okay. You guys, we took care of my left 3. We took care of my down 5. So now all I need to graph of that is an x squared. We got this. If this is my origin, what's 1 squared? 1. So I'm going to say, all right, I would have this point. What's negative 1 squared? 1. How about 2 squared? That's going to get me here. And negative 2 squared? How about 3 squared? 1, 2, 3, 4, 5, 6, 7, 8, 9. Shoot, that's going to get me right there. So here's my original function. And having the exact points is so importante because you are going to use those points to graph the inverse. You down with that? If my function had the point 0, 4, what point would my inverse have?
4, 0.
You got it. I'm going to go to 4, 0. If my function RLS, you got this, had the point negative 1, negative 1, that would turn into, you got it. He's like, okay, that one stays. How about negative 2, negative 4? Negative 4, negative 2. How about negative 3, negative 5?
Negative 5, negative 3.
Beautiful. Negative 4, negative 4?
Negative 4, negative 4.
Last one, negative 5, negative 1.
Negative 1, negative 5.
Beautiful, bud. Thank you very much. Boom. Here's my inverse. Question. Do you agree my inverse was a square root graph?
Yeah.
Isn't the square root graph like this?
Yeah.
Okay, which way would this square root graph had gone? To the left 5, 1, 2, 3, 4, 5. Then what? Down 3. Do you agree that this looks like my square root graph? Where the heck did this come from? What did we forget when we took a square root? What's the square root of 16?
4.
Or, yeah, because isn't 4 times 4 is 16, and isn't negative 4 times negative 4 is 16. So what we were supposed to do right here, you guys, is when you get a square root, we got to say plus or minus right there. I like to say plinus, okay? So I should have put my plus or minus right here. Again, the positive is right here. The positive root is the blue. The negative root, don't you guys agree? The negative roots just flip it over. There's where that came from. Coo. Here we go. We're going to practice this one more time. Here we go. To find an inverse, you always flip the x and the y first. Yep, I love it. Mateo, do it for me. With some enthusiasm, would you?
X.
Equals. Yes, you do. Mateo, right here. Just flip my x and the y of this equation. With enthusiasm. Yes? Yes? Thanks. Okay, so what we always do, first we flip the x and the y. Then we got to get y by itself. What are we going to do first to get y by itself here? Appreciate it. Subtract 2. Ooh, how am I getting rid of a cube? Cube root it. Question, do I need a plus or a minus with a cube root? I do not. Any odd exponent, I do not need a plus or a minus. Any even exponent, I need a plus or a minus, okay? Final answer, y equals, Biscuit, what do you think? Y equals?
Y equals cube root x minus 2 plus 1.
Perfect, thank you, Bisky. Here's what I want us to practice. Ooh, what does this parent function look like? X cubed. What does that one look like? Whoop. Where are we taking that x cubed? Beck, I appreciate your productive comment instead of somewhere. He said right 1, up 2. I dig it. Let's go right 1, up 2. This is my new origin. Boom. Beck, I took it right 1. I took it up 2. You're going to help me, okay? X cubed. What is 1 cubed going to get me? 1. Agreed. What about -1 cubed, bud? Love it. So I'm going to go there. Beck, do you agree if I did 2 cubed, it's 8 and it's too high? What about -2 cubed? But we can, it's worth it, right? Yeah. Okay, Beck, so we are here with my cute little function. That was my original. That's my function. You guys, putting the points is crucial. The points are the only way that we're going to be able to plot that inverse because we're going to just flip them. Annabelle, if my function had the point 0, 1, what would my inverse have? 1, 0. Annabelle, if my function had the point 1, 2. 2, 1. 2, 3. 3, 2. And finally, this one was -1, 1, 2, 3, 4, 5, 6. -1, 6. Would turn into... Wait. -1, -6. My bad. Yep, -6, 3, 4, 5, 6, -1. Again, it's kind of off the graph, but you guys, we really need those points to let us see, oh, this is my inverse. I'm going to put it in green. Inverse looks like that. You guys, our inverse equation was the cube root of x. If this was x squared, and this is square root of x, if this is x cubed, this is the cube root of x. So it does look good. When I say graph the function and its inverse, you guys are good with the function. So graph the function with the points, then flip the x's and the y's to graph the inverse.